Okay, here we are in MATLAB, and I've written a MATLAB function to calculate values of that little equation I put on the board and showed in the previous video. Now, I've done this two different ways. You can see in this first section, I wrote a loop. In the second section, I vectorized it. And I'll go through that in a second, but let me explain what's going on here so you can follow it. Capital N is the number of points I'm going to calculate. And I've decided to calculate them between x equals 0 and x equals 10. So x final is 10. The way I'm calculating it, I don't need to know that x0 is 0. So dx is x final over n. So that's going to be the step size. So right here, I've started a loop, I equals 1 to n plus 1. Why n plus 1? Well, because I want the first value of x to be 0. And I can't start this counter at 0 because the index in MATLAB has to start at 1. Now, some languages, computer languages, will let you start an index at 0, and some will let you start it at 1. It's just a decision that the designers make. MATLAB happens to be one of the languages that the index has to start at 1. So that's I right there. And right here, you can, right there, I guess, you can see that I'm starting at 0 times dx and then 1 times dx. That's working because I've subtracted 1 from the index there. Now for every value of x, I calculate a value of y, and it's just what it was on the board. It's x squared over the quantity x squared plus 1. And I just run through it n plus 1 times. Now this command here, tick, and its partner command talk, are timers. Tick starts the timer and talk stops it. The idea being tick-tock is the sound an old mechanical clock makes. So I guess if you're a MATLAB programmer, that counts as humor. I think it does. So I've done that. And down here, this is the vectorized version now. Now again, I've said tick-tock, so I'll have a lapse time value there. Now rather than go through the loop, I've created a list of numbers that goes from 0 to n and multiplied that by dx. So you can see I've made a variable xx, and it equals all the x values I need all in one vector. Now I called this xx and this yy because I wanted to make sure it was a separate calculation. It wasn't somehow using what was going on up there. So yy is just xx squared over the quantity xx squared plus 1. Now you notice I have to have those dots in there. I've talked about this before, but let's just make sure we know what's going on there. There's a couple different ways to multiply vectors together in MATLAB. There's the dot product and the cross product that you learned in, I don't know, probably linear algebra. But if I just want to go through the vectors line by line or index by index, that's what that dot does. So since I'm trying to do vectorized math, those dots are really important. So for xx squared, what I'm really saying is multiply the first value of xx by itself. Then index 1, multiply the second value of xx by itself, and so on. So what's in parentheses from there to there is a vector, and what's in parentheses from there to there is a vector. Well, if I want to divide two vectors index by index, I also need the dot right there. So that explains why they're there. And so I turn the timer on, run the vector calculation, and turn it off again. So let's run this and see what happens. Let's just give it 100 points. All right. Now the elapsed time is really tiny. You know, it's 154 microseconds for the loop and 19 microseconds for the vector version. Now one thing you might notice, I'm going to run this again, and again, and again, and again. Notice how I get different numbers a lot of the time. I don't get the same answer every time. Well, there's a lot going on inside a computer. I could maybe figure out how to count how many processes are running right now. I probably can't count that high. This is just one of them. So there's some overhead. You know, what is it? I'm not really sure. You're pushing stuff in and out of memory, you know, allocating a processor. I don't know what's going on. But there's a little bit of overhead in addition to just the raw computational time. Now you can see that the vectorized version is running a little faster, but the numbers are so small it hardly matters. Well, let's up it by a factor of 10, right? Still doesn't matter. Overhead is probably dominating the calculation. Okay, now we're getting to the point where the calculations may actually take enough computer time to matter. And you can see that the loop is running a lot slower than the vectorized calculation. I'm still at less than a millisecond for the vectorized version. Let's go up another 10, see what happens. Okay, another 10. So now we've got, let's see if we can do this, 3, let's see, 1, 2, 3, looks like I've got 1,000,000 points here. All right, so now I'm at a meaningful amount of time, enough time it might actually sort of matter. So I've got 160 milliseconds for the loop and less than 5 milliseconds for the vectorized version. So it's holding up. The vectorized calculation is still much faster. Okay, that actually took a noticeable amount of time to return. I'm over a second on 1 2/3 seconds, I guess, for the loop. And the vectorized version is still at 35, 36 milliseconds. What happens if I bump this up one more? Let's try it. Ready? All right, you ready? You paying attention? Go. Okay, that came back. I just made you sit here and wait 16.7 seconds. It seemed like longer than that, didn't it? So the loop ran in 16.7 seconds. The vectorized version was much less than half a second. So you can see that vectorization really does make a difference. This simple little change I made. Now, what's the downside? Well, this is harder to read. You know, once you get used to reading MATLAB, this makes sense. Now, again, I learned to program about a squillion years ago, and so looking at loops makes sense to me. And maybe that's just me, but I think the loop is easier to read than this, at least at first. Now, is there another way to speed this up? Yes, there is. If you look over here, these orange notations, it's complaining at me a little bit. Variable appears to change size on every loop iteration. Consider pre-allocating for speed. Well, what does that mean? It means that it's having to shift stuff around in memory because X and Y keep getting bigger every time I go through this. What if I were to pre-assign this? I would just assign zeros for X and Y before I went into the loop so that they were already allocated in memory and were just being reassigned. That would speed things up. Now, I don't want to have to wait 16.7 seconds again. Let's run this real quick for 10 times fewer points. Run it real quick. Okay, so the loop ran in 1.62 seconds. It'll vary a little bit, but about 1.62 seconds is the number to remember. Now, what does pre-allocation mean? Well, I can go in here and I can say X equals, now I have to call it something. There's a command called zeros, and you can just give it the size of the vector you want. In this case, it's a matrix. It likes to think in terms of matrices. So I'm going to give it a vector of n by 1 length. Well, n plus 1 by 1 length, I guess. And I'm going to make y the same thing. In fact, I'll just call it x. There it is. X and y are the same thing. They're both zeros. And I've made it n by 1 plus 1. So I'm pre-allocating that. Let's run it again now. See, when I click, by the way, when I click down here, see how the save, that floppy disk went gray? When I click down here, it automatically saves, so I don't have to save. I'm going to just pull that up, and remember it was in fact, let's take this out. Let's comment out CLC, so we'll be able to see what's going on here, make the comparison. There. Run it. Wow, look what happened. The elapsed time for the vectorized version didn't change that much, but boy, look what happened when I pre-allocated. The time went from 1.62 seconds to 0.062 seconds. Now, the vectorized version is still twice as fast, really, pretty much. But just pre-allocating that vector really speeded things up. So this is what I meant when I said there's some low-hanging fruit when you're trying to make your code more efficient. A couple of simple changes will make the code run a lot faster. Now, as you've speeded it up and it runs more efficiently, it's harder and harder to get more efficiencies out of it. So you're going to hit a point of diminishing returns at some point. But for right now, if you're going through a loop, go ahead and pre-allocate. Do what it says. Now note, after I did the pre-allocation, it stopped complaining. It's still complaining over here. It's saying you're not doing anything with it. Yeah, I know I'm not doing anything with it. That was by intent. And remember over here, since that's orange and not red, that's just a warning. That's not an error. It'll still run. So by pre-allocating the dimension for X and Y, this ran a lot faster. So by assigning X and Y to 0 beforehand, I pre-allocated it in memory, and now that loop runs a lot faster. So much so that maybe it's almost not necessary in this particular case to go with vectorization. So by pre-allocating, I'm retaining this easier to read code. I think it's easier to read, getting close enough to the speed of vectorized code that I don't need to worry about it anymore. Now, if you'd rather do it this way, the code is shorter. For you, it might be easier to read, and it is faster. So the two things to remember are, if you're going through loops, which is fine, MATLAB doesn't mind at all, pre-allocate your variables if you can. That'll speed things up quite a bit. And the other is, if you want to really speed things up as much as possible, go ahead and vectorize your calculations like this down here. I hope this helps, and we'll talk to you next time.